Hi, this is part one of our review for Algebra 2, and this one focuses on linear functions. Now, the standard form of a linear function is ax plus by equals c. And by definition, the a, b, and c should all be integers. Now, when you rearrange the equation and solve for y, you have the form y equals mx plus b, which is called slope-intercept form. In this form, the value in front of the x, which we call m, is the slope of the line. The b is the y-intercept. It's where it crosses the y-axis. Now, sometimes you're given 2 points and you have to find the slope. The slope formula is y2 minus y1 over x2 minus x1. Okay, so we subtract the y values in the numerator and we subtract the x values in the denominator. So keep in mind the slope is also referred to as the rise over the run. So the up-down change over the left-to-right change. And then if we're given a point and a slope, we can write the equation of the line by using the point slope formula. So if the point is x sub 1, y sub 1, and the slope is m, the point slope formula is y minus y1 equals m times x minus x1. All right, let's do some problems. So the first one says write an equation of the line that passes through the given point negative 5, 8 and is parallel to the line 4x plus 5y equals 15. Now, keep in mind the relationship between parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have, their slopes are the opposite sign and they are reciprocals. So if the slope of 1 is 2/3, the line that is perpendicular would be negative 3/2. Okay, for example. All right, so now let's do this one. We're going to write an equation of a line that goes through this point. So it goes through the point negative 5, 8. And then it is parallel to this line over here. Now, this is not solved for y, so we don't know the slope yet. So first, we have to rearrange that. We have to get the y by itself. And then, to do that, we have to divide everything by 5. So y equals negative 4/5 x plus 3. So the slope, like I said, is the number or the value in front of the x. So the slope is negative 4/5. Now this new line will also have a slope of negative 4/5 because it is parallel. So to write the equation, we use the point slope formula. So this is the x1, this is the y1. So y minus 8 equals m, which is negative 4/5, and x minus a minus 5, so plus 5. So to simplify, we distribute. And then a negative times a positive is a negative, and 4/5 times 5 is 4. Lastly, let's get y by itself. So we'll put it in slope-intercept form. I like graphing that way better. And that is your equation. So both lines have the same slope, so these will be parallel. All right, next, write an equation of the line that passes through the following points. So first, we have to find the slope. So we're going to subtract the y values. So remember, it's y2 minus y1 over x2 minus x1. So the y values, we have minus 5 minus a minus 1. So two negatives make a positive. And then minus 4 minus 3. So now we're subtracting the x values in the denominator. Minus 4 minus 3. So that gives us a negative 4 over a negative 7, which is 4/7. So that's the slope. So then what we do is we're going to pick one of the points. It doesn't matter which one, and use that along with the new slope y minus y1 equals m times x minus x1. We're going to use those in the point slope formula. So let's just use the first one. This will be x1, that's y1. So y minus a minus 1 would be plus 1. Slope is 4/7, and then x minus 3. And now this equation is in point slope form. You could keep it in this form. I typically like to solve for y, so I distribute, subtract the 1, but we'll just leave it in this form for this problem. All right, let's talk about graphing. It says graph 2x minus 3y equals 12 using the x and y intercepts. Now for the x-intercept, we have to remember that the value of y is 0 because somewhere on this x-axis there's going to be a point. And on the x-axis, the value of y is 0 on all of these points on the x-axis. So basically what you're doing is you're covering up this right here because -3 times 0 is 0. So like you can cover that up with your hand. You can't see that when I'm doing it on the board, on this board. But if you cover up the minus 3y, all you would have left is 2x equals 12. And then divide by 2, so x equals 6. So when the y is a 0, the x is a 6. So let me plot that point right here. Next, if you have the 2x minus 3y equals 12, to find the y-intercept, the x is a 0. So basically that goes away. So now you just solve this, so divide by -3. So y equals a -4. So when the x is a 0, the y is a -4, and that's right here. Once you have the 2 points, we can just draw a line, and there's your graph or your equation, the graph of that equation. Now with something like that, the 2x minus 3y equals 12, you could also rewrite that into slope-intercept form and graph it that way. So let's get the x on the other side. So you have minus 3y equals minus 2x, and that's a positive 12. And then we have to divide every term by -3. And so we have y equals a positive 2/3 x, and 12 divided by -3 is a -4. Now, if you're graphing that way, remember first you plot the y-intercept. So on the y-axis, you go to -4, and the slope is 2/3. So up 2/3, up 2/3. And you could draw your line that way. And from that, you could see that the x-intercept is at 6, 0. The y-intercept is at 0, -4. So it's another way to do that problem, another way to graph. Now, let's look at these next problems here. It says graph x equals 3. Now, if you just have an x equals a number, that is going to be a vertical line. I always think this looks like a little v and another little v, so it helps me remember it's a vertical. But what we do is on the x-axis, we go to 3 right here, and we draw the vertical line like this. And that's how you graph that. And technically, there should be arrows on the ends of all of these graphs because they go on forever. They're lines. All right, the next one is y equals -5. And I always kind of think of y looks like an upside down H kind of. And H is horizontal, reminds me of horizontal. So what we do is we go to -5 on the y-axis. 1, 2, 3, 4, 5. And we draw a horizontal line. So that's how you graph those. All right, let's talk about graphing systems of equations. And I shouldn't say graphing them, but by solving them. There are 3 ways you could graph them, see where they meet. And here's a picture of those graphs, and you can kind of see where that's at. Or you could solve by substitution, which is where you solve for x or y and then plug into the other one. Or you can use elimination, and I tend to like that one the best. So like for this first equation, let's say you wanted to cancel out the x terms, like when you add the equations together, you want the x's to cancel. Well, then you could multiply both sides of the second equation by -2, because that would give us a -14x, and it would cancel with the top 14x. So let's just distribute -2 through. And then let's rewrite the first equation underneath it. So now when we add these equations together, the x's cancel. You have negative 16y equals 64. And then we divide both sides by negative 16. So y equals a negative 4. And then to find the x value, you plug that back in to the top equation. So y is a negative 4. It doesn't matter which equation. I just like to use the one that I didn't mess with. So I have 14x minus 8 equals 20. 14x equals 28. And then we divide both sides by 14. So x equals 2. So the solution is x is 2, y is negative 4. And sure enough, if you look at this graph, we go over 2 and down 4. And that's where the intersection is. And also, you can always check your answer because this solution should work in both. So you can plug it into both equations and it should work. The next one says, which of the following lines is not parallel to the graph of y equals 8x plus 3? So remember, to be parallel, the slopes have to be the same. So if this slope is 8, we have to find all the other equations that have a slope of 8. But to do that, the equations have to be in point slope form. So every single one of them, like the first one in 24x minus 3y equals 4, you need to solve for y. So first we're going to move the 24 to the other side. So we subtract. All right, and then to get y by itself, we divide every term by a negative 3. So y equals 8x minus 4/3. That one has a slope of 8. So like, for example, that one is parallel. And with this one right here, you would add 8x, so you would have y equals 8x plus 5. That one is parallel. And then you're going to do the same thing with the next two. Solve for y. Figure out which one does not have the slope of 8, and that would be the answer to this particular problem. Okay, now we're talking about graphing inequalities. Now the first one, we just have an x. And so you need to isolate the variable term, first of all. So you subtract 3. And now we need to get the x by itself. X is getting multiplied, so we do the opposite. We divide. Now here's the thing. When both sides are being divided by a negative, the arrow has to switch whenever we work with inequalities. So 5 divided by negative 5 is a negative 1. So on your graph, if this is negative 1, you put, this is a less than or equal to. So if it's, since it's equal, you put a closed dot. If it was only less than, it would be an open dot. And we want all the values that are less than negative 1, so that is your answer. Now the next one is a compound inequality. And with one like this, I call it a sandwich type, you need to get the variable by itself in the middle. And the thing is, you have to work with all three parts. So first thing we're going to do to get 2x by itself is add 4. But if you add it here, you have to add it to the other parts. So you have negative 10 is less than 2x, which is less than 15. Then what you're going to do is divide by 2. So now x is by itself. Over here you have 7.5. Over here you have a negative 5. So now what we're going to do is, you have to look at this. On this side we have x is greater than negative 5. So if negative 5 is right here, let me see. Oops, I made a mistake on here. I just realized that. This is a plus 4, this is a plus 4, this has to be a plus 4. So this right here, I apologize for that, is a negative 2. So when you divide negative 2 by 2, you get a negative 1. I had done this earlier, and I remembered there was not a negative 5 on this number line. So sorry about that. Going back again one more time, I'm actually going to erase and start over because I don't want you to be messed up on that problem. So we're going to first add 4. So we have a negative 2 is less than 2x, which is less than 15. Then we divide everything by 2. That's better. So we have negative 1 here, and x here, and 7.5 here. Okay, so this is negative 1, and x is greater than negative 1. It's not equal, so it's an open circle, and it's everything greater. But also x is less than 7.5. So 0, 1, 2, 3, 4, 5, 6, 7. 7.5 would be right here. Open circle. And it says x is less than. So in this case, the x values are between these values. So that's how you do that one. Sorry about the mistake on that. All right, next we're talking absolute value. Now, absolute value of x, let's say it equals 5, a problem like that. Inside of here, x could either be a 5, because the absolute value of 5 is 5, or x could be a negative 5, because if it was a negative 5 and you take the absolute value, it would be a positive 5. So to solve these, what we have to do is write two equations. First, we're going to write x plus 2 is equal to 15 and solve for x to see what that would be. But then we're going to say everything inside of there. So again, we write x plus 2, just the way you see it, is equal to a negative 15. So what's on the right side, you have the positive and you have the negative. So subtract 2, x would be 13. Subtract 2, x would be a negative 17. So those are the two solutions that would work for that. Okay, on this next one, we're going to get the absolute value by itself. You always want to do that with these problems. So you have 3x plus 6 equals 30. And we won't finish this for time's sake, but I'll just set up the new equation. So you write 3x plus 6 equals 30, and then 3x plus 6 equals a negative 30. And then solve for x. So let's look at absolute value inequality. So absolute value problems, but we have the greater than and less thans. These are similar. So the first one you write basically like you see it, but we don't write absolute value signs. And then you're going to solve that. Now the second time though, you have to make two switches. You switch the arrow and switch the sign. So switch the arrow, switch the sign. So then x is greater than or equal to negative 7. So in this problem, x is less than 3. So if this is 3, it's going to be less than or equal to. And actually this one is negative 7, and x is greater than that. So it's everything in between there. The next one, we'll write it just the way we see it. And then we'll write x plus 3. Now this time again, switch the arrow, switch the sign. So x is greater than or equal to 2. X is less than or equal to negative 8. So if 2 is right here, and 8 is here, let's say, negative 8, x is greater than or equal to 2. So equal to 2 or greater. And then x is less than or equal to negative 8. So negative 8's here, and less than. So it's a greater, so we go one way or the other. All right, let's talk about graphing absolute values when we're in a coordinate plane. So in other words, when we have an x and a y value. Now the general form of absolute value graphs is this: y equals a times the absolute value of x minus h plus k. When it's in this form, hk is the vertex. So in this case, your vertex is 4, 2. So we go over 1, 2, 3, 4, up 2. The slope on the right side is 2. So we go up 2 over 1, up 2 over 1, up 2 over 1. Now remember, absolute value are V-shaped. So this is the one side. To do the other side, we go back to the vertex and we go up 2, but we reflect it over, so we go back 1, up 2, back 1 up to back 1. So that is that graph right there. All right, that is part 1. Thank you for watching.